Gravity is widely regarded as an action at a distance phenomenon. You let go of the spoon, and it is mysteriously pushed toward or pulled by the floor. Gravity is also a bit spooky because it appears to go through things. An astronaut cannot hide behind a gravity shield because this invisible force goes right through the barrier. Indeed, a prominent Berkeley professor succinctly describes our extensive experience with gravity and clarifies what a theorist is required to explain mechanistically. So, for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Richard Muller, University of Berkeley. Gravity is seemingly supernatural, simply because we cannot see or touch the secret agents Mother Nature uses to do this trick. Yet, if we conclude that no physical object came in contact with the skin of the spoon, we are in effect simulating gravity with spirits and explaining the occurrence with black magic. Under the rope hypothesis, gravity is not an action at a distance phenomenon. It is merely that we cannot see or touch the entities that serve as mediators, the electromagnetic ropes. Briefly, the rope hypothesis proposes that all atoms are physically interconnected by a pair of antiparallel twined threads. It is this invisible, intangible DNA-like entity that mediates gravity. Let's first illustrate the basic mechanism proposed by the rope model of gravity. Imagine Andy and Bob competing in a tug-of-war. Charlie comes over and merely places his hand on the rope, halfway between them. As far as Andy and Bob are concerned, Charlie is inexistent. Charlie cannot pull on Bob at the same time he pulls on Andy. He either pulls on one or the other. The only way that Charlie can pull on both Andy and Bob is by drawing the rope out of alignment on a different axis. Now, let's visualize what the rope model proposes happens between a cube and a cylinder. The gravitational equation describes that a cube is attracted to a cylinder in direct proportion to their respective masses and in inverse proportion to the distance that separates them. Let's interconnect a select group of atoms that constitute each of these two objects with lines to visualize the mechanism. Note that all the atoms illustrated are on the same axis. But what happens to these lines when the cylinder moves closer to the cube? What happens is that the lines fan out. They drift out of alignment and are no longer on the same axis. Under the rope model of gravity, each rope is now acting independently. We refer to the ropes that act independently as effective ropes. The strength of gravity is a measure of the number of effective ropes, which is inversely proportional to distance. Imagine now an astronaut in free fall towards the Earth. The universally certified gravitational acceleration, around 9.8 meters per second squared here on Earth, tells us that the astronaut's weight increases the closer he is to the center of our planet. Therefore, if we weigh him at two locations in outer space, the scale nearest the Earth will show a higher reading. We learn from this that weight is location specific. There is a given weight for each location. Under the rope hypothesis, every atom that comprises the astronaut is bound to every atom that constitutes the Earth. When the astronaut moves closer to the Earth, the ropes that interconnect his atoms to each atom that comprises the Earth fan out. The atoms that constitute his body drift out on different axes and act independently. Summarizing, at great distances, the ropes act as a single coaxial and gravity is weak. At short distances, the ropes fan out and act independently. The gravitational equation is a measure of the effective ropes that bind the number of units of mass contained by each object. As a corollary, this mechanism explains, in passing, the second mystery mentioned by Professor Muller, why gravity goes through things. This is inevitable if all atoms are interconnected. An atom behind another one on the same axis makes one of them irrelevant as far as weight is concerned, like in the tug-of-war between Andy and Bob. It is the decrease in distance between objects that induces the ropes to become effective. The physical cause that underlies the principle of equivalence also comes into view. Imagine a single hydrogen atom at a given distance from Earth. Every atom that comprises the Earth is physically bound to that atom. Therefore, it doesn't matter whether the atom is escaping from the Earth or falling towards it. or whether it's part of an elephant or a feather. The number of effective ropes converging on that hydrogen atom from Earth at that location is the same. As a bonus, the rope model of gravity enables us to understand why stars at the edge of a galaxy do not fly out, and in fact travel just as fast or faster than those on the inside track, a phenomenon known as the galaxy rotation problem. If all atoms are physically interconnected, it means that all stars are also physically interconnected. Think of a galaxy as a gigantic spider web superimposed on all the stars that comprise it. A galaxy is a rotating platform that revolves like a carousel. The galactic magnetic field helps guarantee its integrity.